Okay, so let's talk about another supervised machine learning algorithm that is used for classification problems whenever the target variable is a categorical data type and the categorical nature. That's why we have logistic regression, which deals with classification problems. So just like linear regression, logistic regression has a prediction model. The prediction model is similar to that. We have the same feature space and the parameters as well. The difference over here is that when we multiply the high thetas with x and we get the y hat, we apply an activation function. What an activation function does is that it replaces it with a sigmoid function. The sigmoid function is something similar to this over here. This is what we call an activation function. The activation function puts these values in the over here, and then it gives the output is always between -1 and 1. So in order to better understand it, let's look at the logistic function, which we call the sigmoid function as well. So you can see the answer is always between 0 and 1, and so that is the reason. So whenever we're using the logistic regression for classification problems, we use the sigmoid function which ensures that the values are between 0 and 1. Because the classification problems are either something is true or false, either the image is of cat or dog, so it's either 1 or 0. So binary classification problems, when the possible target classes are 2, we use logistic function for this, and we get this using the logistic regression. So another way to put it in a way that we say that it is a function to estimate probabilities. So when after that we get the activated function value, then we apply a particular threshold. The threshold tells us that if it is less than 0.5, we call it that the value is 0, and if it is greater than 0.5, we call it 1. So the cost function of a logistic regression is of one training instance, and it is parameterized by the logarithmic function. The logarithmic function is used to enable that the cost function is in convex form. So the convex function needs to be implemented, because in order to get to a global minimum, there has to be a minimum value which is parameterized by theta values. So that's why the cost function is parameterized by logarithmic functions, and the math over here is rather complex. So if you want to understand it more, you need to understand the concept of entropy and cross entropy. So let's not go into the mathematical details and understand the concept. We can take it away from here. So in order to understand the cost function a little bit more, whenever the actual value is 1, we have a negative log p, which ensures that log of 1 would be 0. Whenever the value is 0, then it would be 1. So this is a very smart way, and the intuition comes from the cross entropy heat equation. So if you want to understand that a bit in more detail, you should study that. So to understand the optimization algorithm, it's not that different. It is still the same. We're still using gradient descent, and it is almost the same except for the fact that we have an addition of activation function.